For traditional computer-controlled systems, you have to cut your tracks to make isolated block sections. These are wired to a computer interface such that the computer can determine where the trains are. But is that really necessary? Welcome to the official Railmagic Insider series, hosted by the founder of Railmagic. Today's topic is computer control without wiring of track detectors possible. So how is the location actually determined? Well, when the train enters the intersection between the blocks, they send a signal to the computer. The computer can then determine where the train is in that block based on the time. That is because the distance traveled into the block section can be calculated from this equation. It says that the distance is equal to the integration of speed with respect to time. Here computer control systems takes a shortcut by requiring the speed to be a constant. Hence, the equation can be reduced to this. That is, the distance equals speed times time, which is also the area under the curve. This means that for computer control systems, the train must have a constant speed when it enters the track section. The system sometimes have also a sensor in the end of the section, such that the train enters the block section with a constant speed. It runs for a time, start the deceleration, but then it keeps going on a threshold speed very slowly until it hits the final marker with a section, and it can then stop precisely. The thing is that you have to define these cuts in the tracks when you're building the layout. So you have to know exactly where the trains are going to stop, and you have no flexibility. We can say that, well, the train stops in the right position, so that is good. What is not good is that the train is going to slow down and run with this threshold speed very slowly until a final stop, and that is not prototypically. But if you don't want to cut all your tracks, solder wires and connect to a computer interface, that might be a better solution. Where track detectors are not needed, and there are no restrictions to the speed when you enter a block section. Also, the stop locations are unrelated to the intersections between blocks, so you can define a stop position anywhere in the layout. Railmagic can achieve this because we use a codecoder in the locomotive. This is small, very small. It does three things. First, it measures the speed of the locomotive, it measures the magnetic field around the locomotive, and it communicates with the central control unit, this one. So, how does it measure the speed? The decoder in the locomotive makes something that is called back EMF. That is a signal you can measure from the motor. It's a voltage that is a direct representation of the speed of the train. Now that we know the speed of the train, there is no reason to take the shortcut that required a constant speed. The integration can actually be calculated, because an integration is the process of adding discrete values. So for instance, if we know the speed every second, the distance is equal to adding the actual speed values every second, which is again equal to the area under the curve. It has some benefits, and the most important one is that we are able to determine the position of the train even when you control it manually, and you can vary the speed as much as you like. and you don't have to run over intersections to know where it is. This is totally impossible with computer control. However, the speed will be measured maybe a few percentage off, and that creates an offset. This is fixed by having magnets underneath the baseboard at fixed locations. So the codecoder measures the speed, the actual speed of the train, and it measures these fixed locations where it detects it runs over a magnet. This data is sent to this device. And that data looks like the following. So if you have the train moves over the magnets, measure the distance, and it stops somewhere, then we will have a data string that look like this. If you want to know how this device can determine the position of the train from this data string, you have to watch our next video. So don't miss that. There is a link in the description, and you can subscribe to our channel to know when other videos in this series is released. Also, please check our website and hope to see you back soon.